play
that
on
we
Thursdays.
play hide and seek in math class.
I don't know if we're ever going to do that again, because obviously that requires us using classrooms and.
But I love hide and seek. That's why I babysit.
I know, but if we have like a lock-in at the end of the semester, maybe we will.
Wait, was
But
Yeah.
in general, hide and seek is not something I want to make.
Didn't you say you wanted to have a math review, lock-in, study review?
Yes.
Well,
All right, so welcome to math class. Do you have any questions on these? We're obviously going to talk about 11. Anyone you want to see?
Wait, what's the answer to 9?
Answer to 9.
SSS.
Third side.
If it's SSS, then I'm good.
SSS.
what's 11?
It's 15
11 we're going to talk about.
Okay.
15.
It's AAA.
AAA is not a possible solution because you can have two triangles with all matching angles and still be different, right? So AAA is not one of them.
Is it SAA or AAS?
Either way works, doesn't matter which order you write it. Front forwards and backwards is fine. ASA does not work though, right? Because the side isn't between the two angles. It's over here. Is everybody cool with the difference between double AS and ASA?
I don't know.
So the difference between this and something like this is that the side is not in between the two angles when we write double AS. Notice that we have two angles. Here's the side that's in between it. That's not the side we know. So it's not ASA. It's AAS. Because if you go around the triangle, that's the order you hit it in. You can also write side, angle, angle in that order. That works too. So Courtney had a question of why, like for number 16, for instance, why we were allowed to skip a side and write angle, angle, side. So yesterday I didn't really get down to the nitty gritty of it, but in general, if you go from an angle to an angle without skipping an angle in between, that's always okay. If you go from a side to a side without skipping a side in between, that's always okay as well. You just can't go angle, skip an angle, go to an angle. That doesn't work, right? They have to be consecutive angles. That's the point. Angle, angle, side means two consecutive angles followed by a side. Does that make sense?
No.
Two consecutive angles. Consecutive means one after the other. If I were to go this way, then they wouldn't be consecutive, right? Hold on one second. Hold on one second. If I were to count angles this way, angle, skip an angle, angle, they wouldn't be consecutive angles, so I couldn't say angle, angle if I was going that way. That doesn't work, right? Angle, angle, side makes sense because I have two consecutive angles followed by a side. They're consecutive. There's no angle that I'm skipping in between. Same thing here. I have two consecutive angles followed by a side. Again, it's not angle, side, angle because I'd have to skip an angle here to do so, right? It has to be two consecutive angles followed by a side. That's what that means. This means an angle, side, and an angle. So the side in between the two angles is what I'm counting. That's what this one is. So let me find an example of that. Where's an ASA on here? 18. All right, so we have a shared side here. So when I do this stuff, I always cover up one of the triangles. That way I can see what I've actually got here. So it looks like I have angle, side, angle in that order because I have a side in between two consecutive angles. Does that make sense? Angle, side, angle is what this one is. Is this making sense or is it not? It's okay if it doesn't. Please tell me if you're not seeing it. Please.
I'm not seeing it.
Not? Okay, all right. So Z is absent. This makes sense. So I have an angle here, right? That's my green angle. And then I have another angle here. This is my blue angle. On this triangle, I have matching angles as well. So this angle and this angle match up for an angle pair. So we have a pair of congruent angles. We have a pair of congruent sides because they share the same side, right? And then we have a pair of congruent angles. So in order to write down what's going on so I don't get confused and think like I've got angle, angle, side angle or something ridiculous, I cover up one of the triangles so I don't, look at the other stuff. And I just say, look, I have a pair of angles, a pair of sides, and a pair of angles. So angle, side, angle, in that order, right? I couldn't say angle, angle, side for this one because to do so I'd have to go angle, skip an angle, angle, side. I need consecutive angles for angle, angle, side. And they're not consecutive, I'd have to skip, right? So we have angle, side, angle for this one. Words are hard, guys, so I want to make sure you understand what I'm saying here. Is everybody getting comfortable with this?
Yes.
Okay. Hopefully you'll be comfortable on the quiz on Friday. Again, it should be easy if you know what you're doing. If you don't, it can be really difficult because you're just like, I don't know what's going on, right? That's true for anything. But it's very doable if you know what you're doing. It's not going to be something where you're going to be like, oh man, I did everything right, but I screwed up all the algebra, right? There isn't, right? It's going to be a very simple quiz in that regard. Doesn't mean it's easy, I guess, but it does mean it's simple, right? There's not a lot of things you can screw up. But you got to know your crap, as usual. Any questions 1 through 18, other than 11? We'll talk about that. Yeah?
Is the answer to 14 side angle side?
It is side angle side. So far we have side matching and a side matching. The missing angle that she's saying for side angle side, so Zed, the missing angle that she's saying for side angle side is that they share these angles right here because they're vertical, right? So the two big things you need to take away from this, other than the fact that you need to know these acronyms, right, which I think you guys are going to be fine with, is that you need to look for vertical angles, right, because that gets you free matching angles, and you need to look for shared sides, because that gets you free matching sides, right? Those are the things you need to look out for and be able to see. So for instance, if I were to go through this really quickly, matching sides, matching sides, matching angles, matching sides, matching sides, matching sides, matching angles, matching sides, matching sides, matching sides, matching sides, matching sides, right? All that extra information is going to help me out. So being able to see that right off the bat is a really good idea and should make your job a lot easier. And once you have all that, the rest kind of falls into place, right? So look out for those things. The hardest one on here is definitely 11. Because 11, you're going to want to say, oh look, I have a pair of matching sides, a pair of angles, and a pair of matching sides. And when I cover that up, I can see that I have an angle and 2 consecutive sides. And I think we all know what that spells, right?
But I thought you said we can't see.
Exactly. So, this one doesn't work. ASS is one of the two that does not work. AAA does not work, and ASS and SSA don't work. So, ass or ass backwards, right? Neither of those work, okay? That was the joke yesterday. So, that's not enough to get it done. And the reason for that we explained with a drawing, right? It turns out when you do stuff like that, there's only one way that you can make the triangles match, and that's when it's a 90-degree triangle. So Zed, instead of ASS, the only time it works where you have an angle side in that order, or sorry, angle side in that order, the only time it works is when the triangles are 90 degrees. So if this were 90, which it isn't, we can't prove that, but if it were, this would work. We would instead write HL, because what we have here is a hypotenuse that matches and a leg that matches. So we call it HL instead of ASS because it's only going to work with a 90-degree triangle, and 90-degree triangles have a hypotenuse. Okay? So the hypotenuse of one of the legs, that's enough to get it done. Okay? And notice, ignore this. If I know that's 90, then I know this is ASS, right? So if you want to write ASS and it's 90, what you really want to write is HL. If it's ASS and it's not 90, it doesn't work. That's not enough information.
How do you know it's 90?
We don't know it's 90 for this one. We do not. There has to be a different way to solve it. What?
So we still don't know an answer.
We don't. So we're going to go over that today. Was anybody able to figure it out or work with it last night at all? Or talk to some of the 3 kids that figured it out yesterday? I don't care if you do that, by the way.
Who
That's fine.
figured it out?
I believe May, Zayden, and Ellie figured it out.
Ellie.
I think that counts.
Do not be shy. Ellie
I'm
is
not shy. She's
wonderful.
smart.
All right, so I do not like when I say Ellie. Everybody goes, really? Right? Kid's a freaking genius. All right, so let's talk about 11 and how we go about solving this, okay? Before we do that, I'm going to remind you of something, okay? When I do arrowheads like this in the middle of the line, what does that mean? That they are parallel, right? X. That's a transversal, so I'm going to call it line T. And we have 2 other lines that are parallel to each other. Let's give them some names so we know what's going on. I'll do L and M. Cool. You don't have to label them that way. I just like doing it. I think T makes sense for transversal, and L and M stands for line, and then the letter after L, right? Because I can't call them both L's. I suppose I could do L sub 1 and L sub 2, but who cares? So we know that if this is true, right, we have 2 parallel lines cut by a transversal, that means that the corresponding angles will be congruent. these two angles are corresponding because they're in the same relative location, right? They're both top left corner of their intersection. So we have an intersection here, here's the top left corner. We have an intersection here, here's the top left corner. When the two lines are parallel, these corresponding angles will be congruent. Is everybody cool with that? We remembering that?
Yep.
Okay, awesome. We also know that these angles will be congruent here and here because of vertical angles theorem, right? Scissor theorem. Same thing here. Again, these are both corresponding as well. And then same thing with this other set of angles. So this set right here and this set right here are corresponding, right? So they'll be congruent. And then of course their vertical angles as well will be congruent, and these will be congruent. That's the idea. So, let's draw 11 and make it big. So, how do I do this? I think I want to do it this way. Can I use this one again? No, I can't. Wait. Nope, it's mirrored. Okay. So, imagine we have two parallel lines like this. So instead of going left to right, they're just going up and down. Same dumb crap. And they are parallel, I'm telling you that right now. And I had a transversal that's going like this. Okay. So you would know that if these lines are parallel, which I've told you they are, that the corresponding angles will be congruent. So top right corner is going to be congruent to top right. We go with that. And then vertical angles for free, so on and so forth. Okay. So it turns out that we have something very similar to this with number 11. So let's draw 11. Looks something like this. And then we have a line going through it like this. And they've given us that these two angles are congruent. I'm gonna use this weird looking green. Ooh, I like it. And they give us this one is congruent. And they also gave us one of the sides was congruent, and I believe it was the left and right sides, yes. Okay. And then I used red earlier. So these sides are congruent. So we have our two triangles, top triangle, bottom triangle, right? And then you guys notice that, look, shared side. So our top triangle is congruent to our bottom triangle, right? By ASS. Now we know that doesn't work, right? So it's not enough to prove it. So we need something else going on here. It's not a 90-degree triangle. We don't know that for sure. In theory it could be, but we don't know that for sure. So we need some other way to solve this. So here's how you're going to do it. I know that these two lines, if I extend them, are parallel. Here's how I know they're parallel. Do you see this line here? The angle here is the same as the angle there. So this line, I can kind of tilt, and it's tilted to the point where it's the same angle from here as this line is the angle from there. That means these are parallel. Are you cool with that?
Yeah.
Okay, if they're parallel, what we have here is a transversal and two parallel lines. So let's label congruent angles. First of all, these are by vertical, right? Seeing that? Okay. I also know that if I extend these are going to be parallel. I'm not doing a very good job drawing them. I'm using a different black marker. These are also going to be parallel to each other. This. And I know that this angle right here is going to be the same as this angle here because of vertical. Same thing here. By corresponding, right? They match up. We cool with that? This angle here corresponds to this angle here. And then by vertical angles here. So I'll walk you through in slow-mo again. I know these two are parallel as well. I know these are going to be vertical. So they match. I know this angle and this angle matches because of corresponding, right? We have two parallel lines cut by a transversal, right? That checks out. And I get vertical angles here. Notice these are matching because of corresponding, and I get vertical angles here. Now let me cover up a bunch of this stuff. Now that we've got our two triangles, we have more information because now we know these angles match, and we can say that they're congruent by angle, angle, side. So where's my green? Angle, angle, side is enough to get it done. You could also do angle, angle, side this way, right? You got some options here. So this one is kind of crazy, right? But the key to be able to solve it is to extend your lines and realize when they're parallel. I'm going to do this one again because I think a lot of you guys are a little overwhelmed by it, right? Okay. There's going to be one like this in the quiz, definitely.
Oh my gosh.
Can't be more than one.
So really, if any of them aren't easy, we have to do it for all of them because there's a chance that any of them could be like that. All the ones that don't work with these.
I don't think that's the good way to think about that, but I mean, I guess you're sort of right. I don't think that would be a good way to think about that.
Okay.
All right, so let's try this again. Let me get a good black pen. Yes. Okay. So here's what's given to us. We're given two triangles that look like this. We're given that these sides match and that these angles match. Okay? That's all we're given. You guys pointed out that these are shared sides, right? I'm not even going to write that in right now because I know that's not going to be enough, right? Angle side to side isn't going to get it. So I'm just not even going to write it. It's just more for you to look at. So that's what we're given. We know that these two lines are parallel, top and bottom.
Could you do the side ones?
What?
Could you do the side ones instead of the top ones?
These two?
Yeah.
Yes. But in order to do that, you have to prove that they're parallel first. So hold on a second. So these two are parallel, I know, because they're going away from this line at the same angle, right? That's how I know they're parallel. So I'm going to mark that now. I'll use a different color. Parallel, parallel, okay? Because of that, I know that I've got corresponding angles going on here. Same thing with alternate interior. So, I don't want to do this. I'll show you a different way this time. This angle and this angle are going to be the same by alternate interior angles there. That's another way to think about it. Are you with me there? These two angles are the same. Showing you another way of doing it. These two angles will be the same. This big angle here and that angle there will be the same by alternate interior angles. You guys remember alternate interior angles? They're on the inside of the parallels and on opposite sides of the transversal. So we have two parallel lines cut by a transversal. Here's our transversal. Let me cover stuff up. These lines are parallel. There's our transversal, alternate interior angles. Right? Corresponding angles, you do it that way as well. Are you seeing that these angles are congruent? Okay, it's weird because that line's kind of cutting it, but that's okay. So now that I know that by linear pair theorem, these are the same, right? These are going to be the same here and here. And by vertical angles, this. Are we cool with that idea? Feeling better? Okay. Same dumb logic over here on this side. Here's a transversal. Here's two parallel lines. So if you didn't get it that time, it's the same dumb thing over here. So watch. Let me make sure I'm using the same color. These two are the same by vertical. Use the electric one.
Oh yeah,
Okay.
this one.
Still with me? Transversal, two parallels. Ignore this line right here. Okay? These two are the same by vertical. These two are the same. These two right here are the same by cap, corresponding, right? And then by vertical. Same thing here, in here, and here and here. Cool? So what does this tell us? this crap. Where'd my shredded pieces of paper go? Just look at the two triangles. I have a matching side. Let's cover up this one. I have a matching side, and then a matching angle and a matching angle. Do you see the peach and the green angle? So we have angle, angle, side matching here. Double AS.
What about the extra angle at the bottom?
Extra angle is great. If it were just for that triangle, see how it extends?
Yeah.
You see what I'm saying?
Yeah.
So see how we can't say angle, side, angle? Because that angle isn't for this triangle, right? We need to know this angle. If we knew that angle, we could say angle, side, angle, but we don't, right? Okay? I'll do it one more time. I think you guys like that way better. All right.
Are you serious?
What happened?
Mr. Mack, I have an announcement at the end of class.
Yeah, we need to talk about
Or
breakfast
just
club.
right now.
Oh,
Mr.
okay,
Mack,
go
I have an
ahead.
announcement.
Okay,
3 people screenshotted the story of you, so you're popular.
okay. Tomorrow
It
is
was a black screen. Okay, continue.
No, not that.
tomorrow is breakfast day.
Is it annoying when I interrupt you guys and
Yeah.
try to make a talk to the class?
Yeah.
every Friday?
Okay, because it's annoying when you guys do
No,
it.
this is only one. This is
Okay.
only one.
Good job. That's
Tomorrow
I
is
just want to make sure it was annoying for you guys. It is like as annoying for you guys as it is for me, right?
Are people
What's
what's annoying?
Yeah, what's
I'm telling on you.
Okay. Tomorrow
That's just not gonna finish.
tomorrow is
Oh my god.
Taylor, make your announcement.
okay. Tomorrow is breakfast day. So bring a breakfast dish. And if you
No.
don't bring food, you are not allowed to eat food.
And I'm bringing
I'm
chocolate.
bringing
so
Pop-Tarts.
don't bring.
And we already have the drinks covered.
Don't.
Bringing little
Dishes are too
donuts.
hard.
Well,
Pop-Tarts.
just like
Pop-Tarts.
bring a breakfast snack for
I'm going to use the bathroom. Is it okay if I use the bathroom, Taylor?
No.
Are you gonna make?
Never mind, I just had an
He's
announcement.
in here.
Right?
Yes, you may just
This
not.
is you guys every day. When I'm
Yes,
right.
you may just not.
Like I'm right about to make my point,
Actually,
and you
no.
guys are like, I want to do all
Okay,
kinds of crazy
Someone
stuff.
bring donuts.
I will be making cinnamon rolls.
I'll
And
be
Shelby
making-
will have
I may or may
chocolate.
not make apple cider cinnamon donuts.
Okay, that sounds.
I may or may not.
I may or may not. I can't guarantee it. I've been wanting to make them all week,
No.
and I ended up making chocolate covered strawberries
Those are
instead.
way better.
One of the
Someone
joke that I
bring
made.
fruit.
I'll bring fruit.
Taylor,
bring
okay.
fruit.
I'll
Fruit.
bring
Someone bring fruit.
Don't bring
frozen grapes.
Grapes. I'm bringing grapes.
What kind of grapes? Red or green?
I bring their red seedless grapes.
You cannot
Whoa.
participate.
No, but they're way
Who
better.
goes
than
David?
I think that's not.
I love red seedless
No,
grapes.
I think they got
Oh, from the Chinese.
No one bring apples.
All right, now that you've been thoroughly distracted and cleared your palate, right? I'm gonna do it one more time. Here we go.
Thanks for
Oh wait, bad black markers. Alley-oop. Oh,
Bucket.
that was a bucket.
Bucket.
Put it in the right one.
I'm bringing
What the heck?
Yeah, I tried to fix
what happened?
it. Literally me. Now I'm teaching, and look who's up here doing stuff.
Someone
Like I told you, it's not a joke. It's real life. It
Someone
happens.
bring up
Every class.
and we'll make it. That'd be
Is there a
so
microwave?
cool.
What is this song?
Like frozen ice.
It's just.
Oh,
What?
What happened?
Ew.
we want to make
I said we can make frozen pancakes.
Someone should bring a waffle
Yeah.
iron, and then we can make waffles.
Does anyone
Anybody have a George Foreman grill?
I do. I do.
Yes.
I just want to have the smell of bacon when I wake up in the morning.
What
All right.
bring granola bars?
I'm
No.
bringing my cinnamon
I
rolls.
love them.
Welcome to first hour.
I
They
would.
gotta be good granola bars.
They're-
The Chewy brand chocolate chip ones.
I feel like first hour is a good fit for you.
Or
guys.
peanut butter chocolate
Seems-
chip.
I mean, well, it was. I was like, they're gonna work so well together. I'm glad you have Courtney here now. Jeez.
No, the
I
ones
didn't realize Michaela was like, I just need to get rid of this.
We need a kill on the heat. Oh my god.
Yeah.
Who eats that? Those are breakfast. The Nature Valley chewy one.
Whatever they're talking about.
Granola bars.
It's not Spanish. It's just
I eat granola
I
bars.
like sometimes.
We're in fourth hour, right?
Yeah.
So we had like snacks club, but it never got this extreme. Nelly just kind of kept
We're the
herself in
OG
that.
creators of the snack
Oh
club.
wait, or I can bring
We have
my
breakfast
own.
box.
All right. How do you solve a problem like Maria?
I
Wait,
don't
are we
know.
even gonna do
Extend the
that?
lines.
Wait, are we
Extend the
even-
lines.
Which lines do we know that are parallel?
The top
The
one.
top.
The top lines.
So we know the top ones are because they come off at the same angle from this line here, right? So these are going to end up being parallel.
Can we watch SpongeBob more?
No.
Wait, so are we like doing work
We
tomorrow?
get
So they're parallel.
We're
44.
revising.
Let's focus on one transversal at a time. Here's a transversal. So just focus over here.
Alright,
We
time
have
out.
two parallel lines cut by a single transversal. So let's zoom in. That means I know that these angles are going to be congruent, right, by corresponding, and vertical. We go with that? Awesome. Over here,
I think Mr. Max created it.
same dumb crap. I know that when I extend this out, that's the transversal. These are parallel. We already proved that, right? Ish. Again, we'll do this officially next time. Now we're just doing it with pictures. I know, let me make sure I'm using the right colors, that this angle and this angle will be the same by corresponding. And now check it out. I can focus on one at a time. Let's look at the bottom triangle. I've got angle, angle, side. Feeling better?
Yes.
Angle, angle, side.
Actually makes sense.
Okay.
It sounded out loud.
I would encourage you to look this video over
It's
before Friday's quiz so you can get that one. Because I feel like the rest of these are very doable.
So were you live?
I was. I am.
Oh, so we get to listen to my
Oh
announcement
my
again?
gosh, we
That's
can hear
right.
all of us talking
So that
at the
people can
same
actually
time.
Yep.
listen.
Yep, this is
I'll
real
turn
life.
it down, Mojo.
Great.
It's half volume.
You should practice your monologue in front of everyone.
I think that sounds great.
No.
I should not do that ever.
I don't ever you bring fruit ever.
I can't believe this, but I agree with Jericho.
Someone bring
Thank
veggie
you,
fruit.
Matt.
Jesus, hi.
So are we
how
done
you?
for the day?
No.
More difficult.
How do we feel about that?
Can I ask for something better?
I want to.
Do we feel like we understand the concepts? I can go over individually each and every one of these. Or do you guys know what mistakes you might have made and are able to fix them and turn it in Friday?
I think
Can
What
I
if
read
we're
out
already
my
done?
answers?
Wonderful.
And then you have you check them?
I would rather not have to go over every single one, but
I could say
Like,
super fast.
no, like I
Quickly.
just say them.
Wait, what about all the ones that you had to write
I don't
the?
know. I'm turning it in.
What about the second part of it, like on the back?
ooh, good point, good point. That was the thing I was forgetting. All right, so check it out.
Can we just go over the answers?
Here's what it's supposed to be for number one. You're supposed to go back and look at the first question and look at FIG. If you look at FIG,
H-I-G.
it is congruent to HIG. Again, the idea is we want to match the letters up as much as possible when we write that, right? We know the two triangles are congruent, but the way we're going to write it is HIG in that order. You do need to be able to write that.
Wait, what?
That is important.
Wait.
So, Zed, check it out. FIG, this triangle, is congruent to this one. We proved that earlier. We did it by SAS. Now, when we write that the triangles are congruent, we're going to write that triangle FIG is congruent to triangle. Now, I can call it a lot of different ways, right? GIH, IGH, HIG, right? The correct way to write it is HIG because I and G should be in the second spot if we're going to use them again. So IG and then H and F match up. Which makes sense, because when you go back later, now that I know the triangles are congruent, I can label all the angles. These will be the same. These will be the same. Same thing with these sides. Because I already proved the triangle's fully congruent, which means all the corresponding parts are congruent. So, what we're going to talk about more next week is corresponding parts, meaning parts that match up with each other. We talked about corresponding angles, right? Same relative spot, so they're congruent. When triangles are congruent, their corresponding parts are congruent, meaning that F and H, their angles are going to be congruent because they correspond. They're in the same relative spot, right? F and H are in the beginning. I and I are going to be the same. G and G are going to be the same, so on and so forth. So for 2, when we write this, let's write triangle. Which one did they give us for number 2? NOP? Triangle NOP is going to be congruent to what? The bottom triangle. NQP, right? Do we get the concept there?
Yes.
Wonderful.
Yes.
Excellent.
Yes, I do.
That's it for that. Tomorrow we'll have a review guide, which will be very similar to this.
Why does it look?
And then we'll do our quiz on Friday, which is very short, simple, and sweet. If you know what you're doing, you're going to be amazing at it. If you don't, you really won't. So make sure you do know. If you're still not comfortable with this, if you don't feel like you're going to knock it out of the park, please come talk to me. I want you to do well in this quiz. Right?
So this is basically all the quiz, is that?
Basically, it's just this. You'll see what more is on it tomorrow when I give you the review guide, but it is mainly this.
Do you think the bell's hearing? Because it didn't ring.
Nope, go away.